Hi, everyone. Thank you very much for being here with us today. This is actually our first time when we are speaking at a conference like this. Last time when I was presenting something technical was back in my school days, so if something goes wrong, then I will blame stage fright and nostalgia. So how many of you who are here today have the feeling that we are spending much more time actually gathering the information and performing the troubleshooting rather than fixing a problem? So one of the carriers that we are working with last year has an outage, and they received 873 alerts at the same time. There were 40 engineers being involved in the troubleshooting, 4 hours of the troubleshooting, and the root cause was a simple BGP misconfiguration. The problem was actually related to the a BGP community tag that was applied on a routing policy that triggered this cascade of different alerts. So they spent 4 hours to find the problem and then only 2 minutes to fix it. In general, in network operations, all the activities are pretty similar all the time. So when the engineers are starting to troubleshoot something, they're looking at the interface statistics, they're looking at the optical levels, then they're going and checking the MAC addresses, then the ARP entries, the routing adjacencies, the data path, and so on. So it's all the time the same repetitive workflow. So L1, L2, L3, L4, and so on. There is no problem with this process. This is how all of us have learned to perform a troubleshooting. The only problem with that is the fact that it is sequential. So we are doing the same troubleshooting over different networks, different vendors, different protocols, but it has identical reasoning behind it. This led us to a question. So if all the tasks are repetitive and the engineers are doing the same cognitive work over and over again, maybe part of it can be offloaded, especially nowadays when we have such a powerful AI systems that can ingest tons of data, it can search through it, it can perform some thinking and provide some reasoning behind it. All these things started as not as a product initiative, it starts as an experiment and as a research. So it started a long time ago, and as every good engineering team, we had some high expectations over it, and the plan was pretty simple. So connect the AI, feed it with network data, and get the instant insights. Sounds easy, and what could go wrong? So in our first case, we had a pretty easy task for the AI. So we took some BGP configuration from an Arista switch and asked the AI to convert it to Juno's syntax. And here what it presented us. So at the first glance, it looks pretty correct. But then if you look deeper, there is a mix of commands. So 4 commands are from Juniper, and then we have a mix of Cisco iOS syntax and also Arista syntax. A tired engineer at 2 AM may glance at it, try to apply it, and then the BGP session will never come up. But this was only an appetizer. Afterwards, we asked the AI to load a popular Arista routing control function to a switch and apply it. So the task was simple, just SCP the RCF, connect to device, and apply it. So it tried to do that, but it failed, part of it. So it managed to upload the RCF, then it connected the SSH, it tried to apply the configuration a couple of times, it was unsuccessful, then it decided that probably there is a conflict in the config, and maybe it's a good idea to wipe the configuration. So it applied the replace clean config. After this, the AI lost access to the equipment. It tried to ping it, then it tried to connect the SSH, it was unsuccessful. And then it provided some recommended actions. Just connect with a console cable and fix it, which technically is correct, but operationally is traumatic. This whole situation led us to some change in the approach, how we are working with it, and I'll ask my colleague Nick to share more details about it.
So we had to shift our vision on how we build the system. Initially, we tried to just give it access to everything, give it data, because we were on the hype train, right? Everybody believed that AI is the new shiny thing that replaces all humans. Give it access, it's gonna just do everything right. Now we realized we need to build a constrained environment where AI has only access to do non-destructive things. Gathering data is something it should be able to do. Running some commands make a lot of sense, like traceroute or MTR. But wiping a config is not something I wanted to do ever. So we basically built an environment where it has read-only diagnostics, but requires human authorization for any action. Eventually, we got to 3 design principles early in the research. First was the data foundation. I think every single speaker today mentioned that you need quality data to feed the AI. One weird thing is that if you just give it raw data, it looks like it understands it, but it doesn't. So you need some layer that provides quality data, not just all the data. The second thing is the protocol context, because in terms of networks, all ISPs are pretty different, right? And the AI needs to know what your network is supposed to look like, not any network. And you need a health state or some sort of like an image of what AI needs to get your network into, like to look like, for it to be able to troubleshoot the issues that arise. And the third one is the constrained execution. So it has read-only access to whatever it needs to figure out, but it doesn't have access to destroy anything. This is the architecture that we ended up after, I think, a year. Yeah. We're not that big of a company, and we cannot afford to invest billions into research. But there's Google's, OpenAI's, and Anthropic's of this world that publish their research. So this is based on what they architected, right? You can and you should follow the research. There's always new research. If you, I actually heard a lot of people comparing this to N8N workflows. Workflows are a totally different thing from agentic architecture. Workflows are amazing at what they do, but if you want flexibility, you need to go agentic. In our case, we dedicated vertical layering of knowledge, so each agent has its own skills, knowledge base, tools, and they can communicate with each other via the orchestrator agent and to each other directly. And I want to show you a few results that we achieved in a production ISP. Andrian is the network guy?
No.
Ah, oh, right, I have something else. So the Andrian told you about the sequential troubleshooting pattern that all the humans follow, because you cannot realistically just get more data at the same time. AI doesn't have that constraint because it just spawns multiple agents. Each of them has its own responsibility. And we lowered the average time to RCA from 28 minutes to under 4. And now the actual examples.
Yeah. Thank you, Nick. So one of the examples that we had in the same production environment with a carrier was something that everyone in the network operations center may see in a short period of time, like less than 30 seconds. You're receiving 130 alerts or something, spreading across different equipments, like BGP sessions going down, OSPF adjacencies being breaking. Then you have some ICMP unreachability, and you have no idea where to look. This is usually the situation that sends your NOC engineer into a panic mode, so they need a little bit of time to just relax, understand what is happening, and understand where they need to start troubleshooting. And if this is a single incident or maybe multiple things happening at the same time. In our case, the AI performed it very well, so it managed to detect the root cause in under a minute. So in 47 seconds, it managed to point out that the problem is related to a single fiber cut, which is awesome. But the most important thing here is not actually finding the root cause, but also the fact that the AI managed to perform an impact assessment. So it managed to go to the CRM, query it, and understand how many customers are impacted, where they are connected, and provide the list of the customers, which is really awesome. This saves another 10 to 20 minutes from your NOC engineer, that they don't need to go to the CRM and query this information. They have it right away. The other case that we had is also something that happened pretty often. Like, humans are supposed to make errors, and humans may cause outages. So this is not a very critical outage, but let me share more details about it. The business internet service providers that are working with business customers, they are used to add their business customer to some sort of monitoring. Usually, it's just a trivial way adding them to the NMS, putting some ICMP probes, and seeing that the customer is actually up or not. But sometimes this alert pops in, and not all the time they're actionable items, because the business customers sometimes turn off their equipment, sometimes they close their office and just go home, and it's not an actionable item. In our case, it was a real problem. So customer called in and said that they have a problem, so the NOC engineer is lazy and didn't want to perform the troubleshooting itself, so he asked AI to do that. And what is interesting here is the fact that AI was smart enough to look at the logs Actually, it finds initially some key evidence that the port of the customer is up, the data path from the customer to the internet is healthy, so it's not related to the config that is currently in place. But then it was also smart enough to look at the syslog and query it a few hours ago. And it noticed an interesting pattern that an engineer, John Doe, who is always blamed the fact that he's breaking something, connected to the equipment, made some changes, and this leads to a downtime for the customer. And also it was smart enough to look at the CRM and figure out that actually the customer is connected to the port GE000 and not on the GE002 where the engineer performed the configuration, which is really awesome. But not all the cases are successful, and then Nick will share more details about the successful one.
Yeah, because I have to share the bad news. So one example was something that actually both of these are something we still struggle with. We can fix specific instances, but we didn't find a general solution. The first one is we gave AI a task and it fixed it. So we have a customer, he complained that his League of Legends game doesn't go that well because he has high ping. And we like our customers, so we tried to improve his experience. We asked AI, hey, figure out a better path. And there was a better path. There was a router that had a BGP session with somebody who was providing a better path, but we were only accepting the default. There was a reason we were only accepting the default. We don't always have the newest, shiniest equipment in all the corners. You have some old equipment that can handle only so many full views. In this case, it just couldn't handle an extra one. An engineer would know that. AI has a task, AI tries to fix the problem. So actually, I think you've all seen, or most of you have seen, the NetClaw video circling around LinkedIn, where AI adds a static route and it solves the problem, but it's not something you would do, so AI shouldn't do that either. In this case, I think it wouldn't solve the problem, it would crash the router, so we just rejected the suggestion. The second case was weird. I didn't understand it because I'm not the networking guy. So there was a BGP session up for over 30 days. It went down, it didn't come back up. We asked AI to troubleshoot, it didn't find any evidence on any layer, and just said, hey, it's probably layer 3, there's no evidence, but I'm sure it's it, because AI is always sure. In reality, it was a firewall policy change that didn't apply to the existing TCP sessions, but wouldn't allow a new session to form. AI wouldn't go back, it just refuses to go back 8 days because the problem just arose. It doesn't have the concept of time causality if it's over long periods. And I actually think humans struggle with this as well, but humans figured that out. AI didn't. The honest truth is that even though we have a fairly high percentage of successful troubleshootings, we have right now in production 6.4% failures. Most of them are nothing. It's not that important. But some of them, the suggestions are really, really dangerous. A clear BGP at the wrong time is going to destroy our network, so you want to avoid that at all costs. We are increasing the success percentage constantly, but the closer you get to the 100, the harder it gets to get the next one. And the last percent is the hardest percent. We believe, honestly, today, that if anybody promises you that they have a solution for fully autonomous network that just heals itself, they're living in a fantasy world. We will be there, but we're not there yet. The second thing is time and causality. The further apart events are, both geographically or time span, the harder for AI is to correlate the events. It is good at things that are close together, but it gets worse and worse over long distances. And the third one is the context and cost. If you try to throw as much data as you have at a cloud provider, you'll have to pay a very big bill that is more expensive than a human being. You have to design something that is efficient cost-wise. Because it doesn't make any sense to replace a $2,000 human with a $4,000 AI. These are disclaimers. They're design constraints that shape everything we build. Right now, I want to just show off with the production results that we have. We troubleshooted automatically 42,187 investigations over 8 months. 3 minutes and 51 seconds is the average response time, and 93.6 correct troubleshooting according to a human who reviewed the findings. This is not a lab or a simulated environment. This is an actual real-world ISP that basically ran AI in parallel to the NOC team. Key takeaways that we have. Data foundation is not optional. You cannot just push data into AI and expect it to work. You have to process the data. Even though you have machine-readable data, it is not readable by this machine. Human oversight is a design requirement, not a limitation. You have to have a human in the loop on everything that can be potentially destructive. Even worse, you cannot trust AI to decide what can or cannot be destructive. It quite often believes it's not going to ruin anything. Collaborating agents, not scripted workflows. If you want flexibility anywhere, you have to go agentic. We started with NA10 workflows, but they're very limiting. If you want to have some flexible, like human level of interaction and overall understanding, you have to go agentic. And engineering discipline, not API magic. This is not something that can be built in a weekend hackathon or vibe coded in a month. This is a lot of engineering challenges to be overcome, and you have to follow the market and read the research. There's a reason why the big guys work over a year to get something done. Thank you. Andrian?
Thank you very much, Nick. Thanks, everyone, for your time. If you think that we are wrong, come to our booth, and we can present you the system. We can talk about it. We can talk about our research, or you can find us after the conference. Thank you very much.